Okay, so I've already given you guys the whole overview of what one sample t-test. So we are moving straight away to the practical aspects of the one sample t-test. How to apply the theories to what? The application aspects. So now, this is question 1. It was a past question 2020-2021. So the following data gives the income levels in Ghana cedis of a random sample of 18 administrative staff of UPSA. It is believed that the average income level of administrative staffs in this university is significantly different from 1,500. So these are the various incomes they have. So now, based on these data, what we have here, can we conclude that average income of UPSA administrative staffs is significantly different from 1,500? Assume normality. The mean score and mean standard deviation were as follows. So with this particular question, they provided you with the sample size, the mean, and what? The standard deviation. Now we have instances whereby within that same question, they wouldn't give you anything like sample size. Sorry, they will give you sample size. They wouldn't give you anything like standard deviation as well as the mean. So you would have to calculate for the mean and also calculate for what? The standard deviation. But with this particular question, we were given standard deviation, also given what? Mean. So meaning that once we start solving this question, we will just pick the values here and just fix it into the formula we would need in solving the question. That's all. So what we are going to do is, once we are done solving this question using the various answers given here, I would prove it, how we are able to get the answers here. Yes. So I'll solve using this. When I'm done, I'll prove to you guys how they were able to get this answer. They gave it to us in the question. I would prove it. So let's move straight away. So now, with some of the questions, a friend or a colleague might approach you stating, okay, so Prince or Kelvin, what's the difference between one sample t-test and two sample t-test? Now, irrespective of the sample test you are using, they all have what? Their respective assumptions. So with one sample t-test, they have their own assumptions as well as what? The two sample t-tests. So now, since you are dealing with one sample t-test, let's base our focus here. So with one sample t-test, with some of the assumptions, it was in the previous video. So checking from this side, we have a random sample of what? 18. So some of the assumptions, they should have what? A random sample. And the second assumption is, it should have a mean score. And we're given a mean score here. Now, any amount in the question as the mean score. So this is our mean score. When we are solving the question, I would explain it. So our mean score in this particular question is what? 1,500. One would ask, so say, what if I'm giving a mean rate? It's either we use mean score or we use a mean rate. With a mean rate, will be given to you in percentage, like this. So it's either you'll be given a mean score in the question or you'll be given what? A mean rate. They both have the same symbol. This is the symbol for mean score. So it's either the question will give you an amount in question or they'll give you what? A mean rate. They both stand for what? This particular what? Symbol. So with this particular question, we're given what? A mean score of 1,500. So I've already written it here, mean score. So now, checking from this side, we have something like assume normality. When you watch the previous video, you get them. Why I'm picking this stuff. So we also have assume normality. Assume normality in the sense that everything in the question is normally distributed in terms of income. So these are the assumptions underlying one sample t-test. Also, no standard deviation is stated unless otherwise given in the question. So let's move straight to the question. So in solving this question, so solution, the first step, I'll state the hypothesis. In stating the hypothesis, I have H naught, which is null hypothesis. So null hypothesis H2, I have this. Beta 1 is equal to, with the previous video, I stated this side 0. This side, alternative is to Bj is not equal to 0. So in using one sample t-test, this is the approach. Is it okay? It's equal to 0. It's not equal to 0. So this is null hypothesis because of the H naught. This is alternative hypothesis because of what? The HE. Now, this was a format for understanding the overview of what one sample t-test. Here lies the case we are solving a question. So we no more use the 0. We no more use the 0. So in place of this 0, this is where we fix our mean score. So what then do we do? So the correct one is this. H naught is to beta 1 is equal to, what is the mean score? 1500. The next one, HE, alternative is to BG, is not equal to what? 1500. So this is the correct one we are going to use. Perfect. So this is per the format. But once you are given mean score or mean rate, we represent them here like this. So I move to step 2. So step 2, decision rule. With the decision rule, with this side, you notice that some people use one-tailed test. Some people also use what? Two-tailed test. Now, whether you use one-tailed test or two-tailed test, at the final part of your answer, which is the decision side, you'll get the same answers. But with this side, your answers might differ because you're using one sample. Someone is also using what? Two sample. Sorry, one tail test. And another person also using what? Two tail test. But at the decision part of the steps, we should get what? Same answers. So always the first. So this is, I will do this side here, one-tailed test, and also solve the two-tailed test here for you to get the difference. This is two-tailed test. So always with the decision rule, the first thing is, let me do it A, your level of significance. Level of significance is denoted by alpha. Now, in the question, or per one-tailed test, or whenever you are given a question with respect to one sample t-test, the level of significance is always 5%. If the question gives you an actual percentage, then you use that one. But if it's not stated in the question, you use 5%, which is 0.05. Now, once you are using one-tailed test, you only state the level of significance like this, 0.05. Now, with two-tailed tests, your level of significance, you divide this by 2. So I have 0.05 divided by 2, which gives me 0.025. So that's the difference. One-tailed test, you only state the level of significance, 0.05. Two-tailed test, you state a level of significance, divide by 2. So this is our actual level of significance. This is the same level of significance you are using. Then the second part under the same decision rule is what we call so that's degree of freedom. So with the degree of freedom, it runs through the same thing for both tailed tests. So we have degree of freedom. So degree of freedom, df is equal to n minus 1, where n is the sample size. So I have this. N is given in the question. Random size sample of what? 18. It was even stated here, n, 18. So this is 18 minus 1. Degree of freedom is equal to 17. So for the degree of freedom, it's for all the tests. We don't have differences. Whether one-tailed test degree of freedom or two-tailed test, no. This is the general degree of freedom we use. So this is level of significance for one-tailed test. If you are using two-tailed, you divide it by 2. So the final thing we do is we need what we call the T critical. So the T critical I'm doing here is for one-tailed test. The T critical I'm about to do the other side is for two-tailed test. So T critical. This is alpha, comma, this is DF, degree of freedom. So with the T critical, alpha here was 0.05. Degree of freedom here was 17. Now once you get to this point, we use a table in finding the answers here. Now, with one sample t-test and multiple linear regression, we also use a table. With multiple linear regression, the table is always the first one given in question. Then the second table that will be given in the question is what we use for what? The one sample t-test. So with the table, we have something like this. This side is the alpha, level of significance. The first one is 0.025. This is 0.05. This side is our degree of freedom column. We have 17 here. This is 0.05. This was our one-tailed test. The one-tailed test, the level of significance. This was our two-tailed test. Level of significance. So what you do is you match this level of significance and also match this degree of freedom. Where they are meeting, we pick that number. So I'll try and attach the table to the video so that you compare the answers we are getting here to what you'll be getting in the table. It's the same thing. So once you pick the table, match the 0.05 and also match the 17. Where they are meeting, you get 2.110. Now, when you match this 0.05 to also where the 17 is, what this side, from the table, you get 1.740. So I'll attach the table to the question so that you get to know how we are getting the answers here. So this side, so 0.05 and 17, 0.05 and 17, we have this, 1.74. So 1.74. Now, this side to alpha, degree of freedom. So this is T critical. Alpha. Now the alpha here is what? 0.025. 0.025. Degree of freedom, the same thing, 17. Let me write the answer down here. Now, with this side, 0.025 and 17. So 0.025, you match it. You also match it. So where they are meeting as the T critical. So this is 2.110. So we are done with the degree of freedom. So now with the decision rule, we are done. At the end of every decision rule, this is what we are looking for. We want to know what our T critical is. That's the whole concept. So you could see that from this side, if you are using one-tailed test, this is the answer you are going to get for your T critical. And if you are using two-tailed test, this is the answer you are going to get for your T critical. So you could see there's a difference here. But when we get to our fourth step, which is the decision, we are supposed to get the same answers at that particular side, which indicates that our T critical is perfect and it's correct. So now, so this is step 2. So step 3 is what we call the computation. So with the computation, we use what we call the F-statistics. Now, with this F-statistics, we have a formula we use. We have your mean minus your mean score divided by your standard deviation, also divided by square root of your sample size. So our mean, we have this, which was given in the question as 2441, 2411. So 2411. Sorry, the mean is 2411. There's it. So we have mu. This is the mu. This is where we fix either the mean. That is where we fix the mean score or the mean rate. Take note of this particular side. This is where we fix the mean score or the mean rate. So we have mean score. So the mean score in the question was given as well. I told you it's any amount in the question, 1,500. So mean score, 1,500. We need standard deviation. So with the computation I'm doing here, I'm picking all the values from the question. So we're given this. So this is what I'm fixing there. With some of the questions, they wouldn't give you the stuff. You would have to calculate the mean yourself and also calculate what? The standard deviation. So when we are done with everything, I'll show you the proving method, how to prove the answers here. So standard deviation, we have 911.6878. So we have sample size, which is the n. We had 18, so we substitute them into the formula. So F stat, so mean, we have 2411 minus mean score 1,500 divided by standard deviation as 911.6878 divided by square root of sample size, which is 18. So we punch this on the calculator. (2411) minus 1500 divided by 911.6878 divided by square root of 18. So we have F starts to be 4.239, which is approximately 4.24. So this is our F start. So we are done with step 3. So step 4, this is where we deal with the decision. So with the decision, if your F stat is greater than your T critical, it's significant. But if your F stat is less than your T critical, then it's not significant. Not significant. So we will compare our F statistics here against the T critical here. So since we used 1 tail test and 2 tail test, so we are going to have 2 decisions here. But when you are solving the question, please don't use both. Don't use both tests. Use just one. Either you would use the 1 tail test or you would use the 2 tail test. I'm using both in this question because I want you to get the difference. That is the same thing. So you can decide to pick 1 tail test or you can decide to pick 2 tail tests, but don't use all the two, just pick one. I just want to show you that at the end of this decision, although we are getting different T critical, our decision should be what? The same thing. That's the concept. So So with this side, we had, so our F stat here is 4.24. So let's compare it against the first statistical. It's 1.740. Now the F stat again, 4.24. Let's compare it against our statistical, but the two-tailed one, which is 2.110. If this F stat is greater than this, then it's what? Significant. If this F stat is less than this, then it's what? Not significant. So this is greater than this. So we have significant. This is also greater than this. So we have significant. So as you can see, we have significant for the one-tailed test. We also have significant for what? The two-tailed test. So irrespective of the test you are using, you should get what? The same answers. So if you use one-tailed test, if I'm using one-tailed test, I'll get my decision to be significant. If Kwabena decides to use two-tailed test, he will also get what? Significant. So just pick one of the tests, then you are good to go. So this is the fourth step. So with the fifth one, that's where we have the interpretation. So with the interpretation, it's based on the answer you are going to get from the decision. So the question we are solving is, it was stated from this side. Can we conclude that the average income of UPSC administrative staffs is significantly different from what? 1,500. What you are saying is, per your final answer you are getting, can we conclude that the average income of UPSC administrative staffs is significantly different from 1,500? So if the answer you are getting for this side is insignificant is a wrong grammar, not significant. If the answer is yes, not significant, meaning that we cannot conclude. I don't know if you guys get a concept. This side we are getting significant. So yes, we are saying, can we conclude? And our answer is what? Significant. So this is how we state it. Yes, we can conclude that the average income of UPSC administrative staffs is significantly different from 1,500. But assuming our answers we are getting here is not significant, we state that no, we cannot conclude that the average income of UPSC administrative staff is significantly different from 1,500. So let's focus on our answer. We had significant. So I pick it from here. So can we conclude? So yes, we can conclude that the average income of UPSC administrative staff is significantly different from 1,500. That's all. So assuming your answer is not significant from this side, it's not significant. No, we can't conclude that the average income of UPSC administrative staff is significantly different from 1,000. So that's how we solve one sample t-test question. So that's all. So always take notes. So assuming we were given a mean weight, I'm done with this. Assuming we were given a mean weight of 4.5%. If I'm solving this particular, assuming there was no mean score, it was a mean weight. With this particular side, this side, this is how I'm going to do it. It becomes 2411 minus 4.5 divided by the standard deviation 911.6878 divided by square root of 810. So one would ask, but this is percentage. Why didn't you convert it here? With mean rate, we don't change it. We don't do it 0.045. We don't convert it. You just ignore the percentage and fix the mean rate at the side. That's all. That's the difference. Either you'll be given a mean rate or you'll be given what? A mean score. We just fix it here. We mean score, it's an amount, so you just fix it there. If it's a mean rate, you just ignore the percentage and fix just the number there like this, 4.5 there. So with this side, we used what in solving it? We used the answers that they gave to us. So I'm going to show you the proving technique or the proving format in getting the answers here using the calculator. So this one, they gave it to us. So I'll show you how we can use the calculator and how you can also what? Solve it. So we are proving just the answers here. So I'll clean this one as well. So let me show you. I'll show you the calculator approach. So calculator approach. First, once I'm done with this, I'll also teach you how you can do the calculations as well without the calculator. So with the calculator approach, what you do is, step 1, press mode. So step 2, select start, which is 2. Step 3, select 1, which is 1 minus VAR. Step 4, you would see a table like this. This side has numbers. This side is written as X. This side has numbers. This side is written as X. So with this column, type all the numbers here in this column. All the numbers we have here, the income, type them in the X column. So I'm starting. The first one is 2230. 2230. The second one is 2745. The third one is 3100. The next one 1215. Once you press any number, you tap on equals to move to the next one. So I just finished with 1215. So I'm moving on to 1827, 4110, 2590, 2020, 1923, 1239, 1050, 1280, 3850. So this is the calculator approach. You press mode, you select start, which is 2. You select 1, it states that 1 minus VAR. The fourth one, you'll be given an X column with numbers here. So in the X column, you type all the income here into that column and press what? AC. Once you press AC, it comes out as 0. Then step 5, you press shift plus 1, which states that what? Start. Then step 6, you select 4, which is VAR. Then step 7, once you select 4, which is VAR, the starts pop up. You see an N. You would see this. You see all the variables here. So if you want to find N, you just select 1. You get the N here, which is 18. With this one, this stands for what? The mean. So once you want to get, or you want to find for this mean, you start from this side again. So shift plus 1, you select this. Then now select 2, which is this. So we got 2411.33, approximately 2411. So the same as the mean that was given to us in the question. Then you still press shift plus 1. Select 4. Now we want standard deviation. So we select this 4. We had 911.6878, which is the same as this. So basically that's how we do. So this is the calculator approach in finding for the answers here. So now, we've solved the situation whereby they are giving us the N, the mean, and what? The standard deviation. And we've also solved it using what? The calculator approach. We will also now show workings, how we can get the numbers here. So with the proving method, this side is my X. So I'll fix all the numbers in the table at this particular column. So the first one is 2230. The next one is 272745. The next one is 3100. So the numbers here, you write them. So 1215 1827 4110 2590 2020. I have 1923 1239 1050 1280 38 50 2228 2986 2573 2938 3500. So these are all the numbers for X. So what we are going to do is we will add all the numbers, and that will give us sigma X summation. So sigma X. So we'll add everything up. So let me open it. So add all the numbers here. Now when you add all the numbers here, we are getting 43404. There's the total when you add all the numbers. So the next thing we are going to do is we are going to square all the numbers here. All the numbers we have here, we'll square them. So this is x squared. So this number squared, then write it there. Okay. So all the numbers here, we'll square them. So the first one is 2230 squared. 2230 squared will give us 2230 squared would give us 2230 squared will give us 4972900. The next one, 2745 squared would give us 7535025. The next one, 3100 squared will give us 961401234. 1215 squared 1476225. The next one, 1827 squared. This is 3337929. 4110 squared 16892100. 2590 squared 6708100. 2020 squared would give us 40804000. We'll square this one as well. 1923 squared 3697929. 1239 squared 1535121. 1050 squared 1102500. 1280 squared give us 1638400. 3850 squared would give us 1482250. The next one, 2228 squared would give us 4963984. 2986 squared would give us 891616. 196 2573 squared would give us 6620329. 2938 squared would give us 8631844. Then 3500 squared would give us 1225. 4 zeros, 1, 2, 3, 4. So what we do next is we'll sum everything and we'll add everything. So this will give us sigma x squared. This is sigma x. This is sigma. Since this one is squared, we'll add everything up. So we get sigma x squared. So when we add everything up, you are getting 118791,482. When you add everything, this is what you are going to get. 118791,482. Okay. So per what we have here, in finding mean, this is mean. Mean is given as this. Mean is sigma x over n. The sigma x, we have 43404. So this is 43404 divided by n. N was a sample size. We counted it. It's even, this is the n. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So the n is 18. So our mean is equal to 43404 divided by 18 would give us 2411.3, which is approximately 2411. So that was what was given to us in the question. This is it. So now we are left with what? Standard deviation. With standard deviation, so this is the proving method. So I've solved the mean. I'm left with standard deviation. With a standard deviation, this is the formula we use. In getting the standard deviation, we have this. It's so this is 1 over n minus 1 square root. This is sigma x squared minus 1 over n times sigma x, then you square it. So now sigma x squared, I already have it here. This is it, sigma x squared. This is sigma x squared. Sigma x, I already have it here. So I'll substitute them into the formula. So this is x squared. This is 1. N is 18 minus 1. I have this. Sigma x squared is given as this. 118791,482 minus 1 over, this is n, so 18 times sigma x, then you square it. So this is sigma x. So 43404 squared. So you have s squared is equal to 1 over, this is 17. So I can do the 1 in brackets together. So this is 118791,482 minus this. 1 over 18 times 43404 squared. This is what we are getting. 104661,512. So we can point this together. So 1 over 17 times 118791,482 minus 104661512. So we have x squared is equal to 831174.7059. So this is what we are getting. Now, so one would state, but you are saying that once we use the calculation approach, we are supposed to get the answers here, because the first one 2411 we got to this is it. The n is 18, we counted it here, we got the 18, we are left with the standard deviation. Now once you end here, this number is what we call the variance. That's one. But you want what? Standard deviation. So what we do is, that's why it's even given a square here. Assuming it's just an x, then it becomes a standard deviation. But it was what? X squared. So standard deviation is square root. It's automatically, so we have this. So out. So s is equal to, this is what? The variance. So standard deviation, the variance is this. 831174.7059. So our standard deviation is equal to Square root of 831174.7059. So we have 911.687836, and they had 911.6878. 911.6878. So this side, we only pick up to this point on the calculator. So this is our standard deviation. This is our standard deviation. So this is the proving method. This is how you can prove the answers there. So this is all about one sample t-test. So you can watch the theory part of it before you come to the calculation aspect. So without much I say, we would end here for the one sample t-test.